yesterday's session, meaning how to create a domain from scratch and how we can make use of that particular domain in order to what I call take care of data quality activities. Now, let us try to get connected to that particular domain by supplying the credentials like username and password. Yeah, yeah, you can treat that S1. Yeah, it's a normal class, but you can treat this like a what you call demo or whatever. Yeah, fine. Yeah, so as we all know that we have talked about what you call Informatica information management life cycle, yeah, where I was trying to talk about what we call different layers within the data quality or within Informatica. Yeah. Can you see here? We have different layers over here. Yeah. Access, discover, cleanse, integrate and deliver. So we have different layers. Out of them, in this particular training program, we are going to focus on what we call discover layer and what we call cleanse layer. Remember, which means discover layer will be used in order to carry out the analysis and cleanse layer or quality layer will be used in order to take care of what we call carrying out all the quality activities like we have parsing, standardization, enrichment, match and merge. All of them will be taken care of by using what? Cleanse layer, right? After that, we have talked about what we call architecture of what we have within the data quality, where you can see three layers within this architecture, where we have client layer, which contains what? Informatica analyst client, which is going to be the what I call web-based client, and then we have Informatica developer client, which is going to be the standalone client, yeah, which I was trying to open over here. This is the Informatica developer, right? Yeah, and then in the server layer, where we have different services belongs to what I call data quality server, like we have what I call model repository service, data integration service, analyst service. Where do you see them? You will see them as part of admin console or administrator, where we could able to see all the services of what is needed for carrying out data quality operations. Yeah? So which means what? We need to make sure that all the services like whatever you could see as part of architecture, which means for data quality services, they need to be created before we start making use of either analyst client or developer client. Yeah? So which means we need to log on to admin console and start what I call creation of those services, right? So I was trying to say model repository service, data integration service and analyst service. So they are all part of data quality server. Yeah? And then we have meta layer, which means where we are going to store metadata that is required for carrying out all metadata operations. Yeah? Right? So we have model repository service. Can you see here? This is the first service. Second is what? Data integration service, which will be used to move the data from one transformation to other transformation. And analyst service will be used for analyst client to carry out web-based analysis. Yeah? So that's it. Yeah? Now, once you bring up these clients, so we'll start with what I call Informatica Developer Client, which is going to be the what is a standalone application that will be used by the developers to carry out all data quality operations. Remember, yeah? So we are going to use this Informatica Developer Client in order to perform data quality operations. Yeah? So which is what we do by using what we call Informatica Developer. Yeah? Now we know how to bring up these services which is required for data quality. Yeah? Once you bring up these services, then by using admin console, after that we need to log on to one of these clients so that we can get connected to those services. Yeah? So that is what we have discussed so far. After that, we need to do what? We need to start creation of what I call domain. Yeah? So by getting into Windows, Preferences, and then you will see what we call domain. Can you see here? So this is what need to be selected in order to what I call create a domain over here. Yeah? You can click on add and build any number of logical domains. Remember, creation of domain by using this particular data quality tool is not similar to Power Center. In Power Center, you guys need to use same domain as what we have within this admin console. For example, here we have domain underscore RISL server. Same domain name need to be used in Power Center. But in data quality, we can have any number of logical domains, which means what? This is what I call logical domain, which we created here. Can you see here? The domain name is different from what we have in admin console, right? In this case, we have domain underscore US underscore something else. But if you go and look at admin console, which is different. So internally, this particular logical domain will be mapped to the physical domain of what we could see in the admin console. After that, we need to supply host name through which we can start what I call get connected to that particular domain, which means what? Wherever this particular domain, what I call has been set up, you need to specify that particular host name. Yeah? And then port number where that particular domain is listening to. So this is a default port number which you guys would have used even in Power Center. Yeah? And then make sure that we could able to get connected to that particular domain. Once it is done, connection will be successful. Clear? So this is what need to be done while creation of a domain, right? Once we are done with that, next step is going to be what? We need to start getting into file and connect to the repository. So that's the first thing you do even in what I call Power Center also, right? Same thing we need to do over here. The difference here is what? The repository of what we use in Power Center would be different from data quality. In Power Center, you are going to create what we call Power Center repository service. Can you see here? Click on this domain where you can see this Power Center repository service, which will be used in the Power Center. But in case of data quality, we are going to create model repository service, which is going to be the repository that will be used to store or to take care of what we call all repository operations. Fine. Which means what? We need to create model repository service. That was created as part of this what I call admin console. Remember. Yeah. So once we are done with that, then we could able to connect from here to that particular repository service. Can you see here M? Where do you see M? This is the M, which is what we call model repository service. So we need to make sure that it has been created and it is up and running so that we could get connected to that particular service. Sorry. Fine. So now it is up and running, so we could able to talk to that particular model repository service. Yeah. Now the next thing is what? Once we are done with that, next thing is what? We need to start creation of what we call project and folder. For that we use new project, which is what we did here, and then underneath we can create any number of folders. Yeah. Yesterday we created one folder by name folder. Let's say one more folder by name folder 1. Likewise, the project is a collection of set of folders. So we can create as many folders as you need depending upon the kind of the requirement that you are going to deal with for your project. Yeah. After that, what we did was we have created data object which we call physical data object based on a flat file based on relational table. Meaning what? Let us say if you get data from sources like from flat files or from relational tables or from, let us say, some other types. For that, what we need to do, we need to find a way like how to get connected to what we call those sources in order to read the data from those sources. Let us say in order to read the data from flat files, we need to use flat file data object through which we can create a flat file data object based on flat file. Yeah. Now we can browse to a location where we have flat files. Let us say orders flat file, which is going to be the CSV file, and then supply that name of this particular flat file data object. In this case, orders is going to be the what I call flat file data object. Yeah, and then click on next. Yeah, and supply what I call delimited or fixed width, and then specify any delimiter like whatever delimiter that you have under this for this particular flat file. Yeah, and then the next thing is going to be what we need to get into this import column names from first line, which is straightforward. In case if you have header, you can select it or else no. And then we have start at line, from which line you need to start reading the data. So that also we need to specify as part of this particular import. Yeah, and then followed by row delimiter. Yeah, and followed by what I call specify treat consecutive delimiters as 1 in case if we have, or if you want to treat multiple delimiters as what I call 1. Yeah, and if you have any escape characters which you want to what I call take out, which means if we don't want to take care, then you can just specify what not to be taken care by specifying appropriate characters. And if you want to transfer escape characters to your target, we can do that, or else you can just skip them. Yeah? And then once you click on next, where you could see columns in the top and data in the bottom. So you will have what you call both the options, yeah, as part of this, and say what you call finish. Click on finish button so that we could able to see what we call how to create what this particular data object based on a flat file. Yeah. So these are the sequential steps that need to be followed in order to create a flat file data object from scratch. Clear? So once, likewise we have, yesterday we created 2 flat file data objects, right? Today I have shown one more. Yeah. Now we know how to create data object, which is exactly similar to what you do even in Power Center. Only thing is some interface is different, yeah, which is not complex, but actual storage starts from here. Yeah. So what do we do once you get the data from this particular flat file data of flat file? So what we are going to do here is, as we discussed just now, if we talk about this life cycle, what do we need to do? We need to discover the data. We just did what this part, access part, which means what? How are we going to read the data from this particular flat file? Yeah? Now, once we do that, what do we do with that particular data? That is where profiling part would come into picture. Yeah? Yeah, there's a question from Srini. Can you show example with a table? There's a question. So which is straightforward. Let us do that. So again, right click on this folder, new data object. We need to select what I call relational data object, because databases are in compliance with what RDBM is, right? Relational Database Management System. So that's a specification. So then select that particular type of physical data object, which is relational data object, and then browse to a location where you have connection details, or you can also build your own connection and say OK. Now then browse to that particular connection and get the appropriate table, so that we can start what we call creation of data object based on that particular table. Clear? Now uncheck this particular checkbox where you will see all the schemas, not only just DWH7, we can also see even other schemas also, HR, all that, yes or no. And then specify any table which we are going to use in order to create a data object. So in this particular case, we have what department table we have just selected, and say what we call OK. Yeah. Once we are done with that, then what happens is we are going to create what we call data object, which is going to be based on what department table. Yeah. And we can supply any name in case if you want to supply meaningful name, or else we can leave it as it is. Yeah. And this particular data object will be stored under this particular location, which means what? Under model repository, which is M, under that project which we created, and then underneath we have a folder. Yeah. So in case if you want to change this to some other location, browse to a location and specify the location where you want to store this particular data object. Yeah. And then say OK. After that, finish it. These are the what I call very straightforward steps that we are going to follow in order to create what I call data object from a scratch. Yeah. There's a question now, what I call from Chandra. What is a workbench in IDQ? Remember, actually the workbench term that we used to use in pre-9.x data quality versions. Yeah. So workbench is what I call this working environment, like what we are doing. So in this case, Informatica developer, it is going to be the workbench which will be used where to carry out data quality operations. Chandra? So this is a 9.1 version of data quality, and we also talk about 9.5. We have both the versions. Can you see here? 9.1.0, 9.5.1. So both the versions will be covered as part of this training. Yeah. So 9.5.1 is the latest version which we are going to cover as part of this training with all the features that are being supported by that particular version. Chandra? Fine. So once we do that, then the next thing is going to be what? We need to start getting into what we call what do we do? Now we know how to create a data object based on flat file, based on relational table. So after that, I also talk about how to build a service by using WSDL, which is a web services definition language. Now it is too early to get into that far. Now let me start with what we call understanding the kind of data that we have either in relational table or in what we call flat file, which is what we are going to talk. Which means what? There is a question from Yashwant. All these data objects are logical or they are physically stored somewhere. They'll be stored in this what we call model repository. Yashwant? Yeah. So which means the data objects of what we have created here, all of them will be stored under model repository, this one. Yeah. So where we will have the predefined metadata plus the custom defined metadata. The one that we define here is what? Custom, which means we ourselves define what we call metadata. Yeah. Now the next is what once we know like how to create this particular data object, next step is going to be what? We need to start getting into what we call creation of or understanding the kind of data that we have in this LA customers file. Yeah? So which means if we go and look at this particular flat file, let me try to get into that. Let's say we have what we call developer client, and underneath you will have a developer client and then tutorials, then let's say any file. So this is a file which I was trying to talk, right? Yeah. Here we have this kind of what we call data. Now we need to understand the kind of data what we have here. To do that, we have what we call discover layer, which I was trying to talk in the life cycle. Can you see here? Discover layer. So this layer will be used in order to understand the kind of data that we got from the source system, or analysis layer. This means we use discover layer in order to carry out the analysis. Yeah? So which is what we are going to what we call do. That is where we use a term of what we call profiling. Yeah? So which means we are going to profile the data of what we have seen. Yeah? Let us start creation of what we call profile data object. For that, we need to select a folder, new profile, and select the individual profile data object, which is going to be the middle one. Yeah, yeah, we can also do that. Chandra, I'll show that as well. Yeah. So let's understand one by one. Let's understand we have good data in the flat file than relational table. Yeah. Same thing, there is no difference at all with respect to these steps, right? Whether you are going to take database table or you take flat file or you take even XML or you take some other particular type, right, which is same. There is no difference at all. Yeah? Like we created data object, right? That's also same as what we did for flat file. Only thing is database connection details we need to supply. That's all we need to do. Yeah? Now, let us start with what we call creation of profile data object, which is single data object profiling based on LA customers. Yeah? LA customers table, right? Sorry, flat file. That's it. And say what? select data object which you are interested in over here. Let's say LA customer and say OK. So which means what? We can pick up individual data object in order to carry out what we call profiling. Once we are done with that, then enable the checkbox which indicates what? Run profile on finish, and say finish. That's it. So which means what? We are trying to what we call carry out column profiling. Remember, which means what? Each column data that we are going to understand in terms of duplicacy, in terms of nullability, in terms of metadata issues, in terms of range data, in terms of pattern issues. That anyway we are going to talk, which means what? We are going to understand whether we have like how much is the duplicate data we have, or how much is the bad data, how much is the good data that we got from the source. So that is what we call, that is what we take care as part of what we call profiling. Yeah. Let us start doing that. So now we know like what we call how to So now we know, let me just try to put it here. I'm trying to reorganize these things. Okay, perfect. Now we have this, what I call LA customers data object. Let us understand what I call the kind of result that we got. Can you see here? Here we have this what we call column profiling. Wherein you could able to see what different columns on the left side and the detailed properties on the right side, which means what summary attributes you can see on the left side and detailed what you call data you could able to see on the right side. So that's what you could see here. Now let's understand one by one, like what do we get from this particular profiling output. That is what I'm going to explain now. So just to start with, column profiling will be used in order to understand the data for each and every column. To answer that, we have several attributes to understand each column data. So broadly, there are two types of attributes. One, summary, what we call attributes or summary properties on the left side and detailed properties on the right side. Let us start with summary properties, which includes what? Unique values, which means what? How many number of unique values that we have from a given source. So totally we have how many rows? If we look at here, where I am trying to place the cursor, where we have how many rows? 500 rows. So this is what we executed, right? December 25th, 2011, 6:31 AM IST, which means if you go and look at this system date and time, so that will be displayed as part of this, what we call statistics. Then the next thing is what? Each column we are trying to understand now. First column is what? Customer tier, where we have 12 unique values. Remember, I repeat, there are 12 unique values, which is what we are going to what I call understand. 12 unique values. What are those? Diamond, ruby, emerald, till what I call diamond 1. These are all, if you just count the number of unique values, it should be what? 12. So out of 500 rows, we have 12 unique values. Then the next is what? 2.4 percentage, which is what? Percentage of uniqueness. Meaning what? How much is the percentage of unique data or percentage of duplicate data of what we have. Yeah. So for example, here we have 2.4, which indicates what? 12, which is total number of unique values divided by total number of rows, which is 500 into 100 is equal to what? Percentage of uniqueness, which means what? 12 divided by 500 into 100 equal to 2.4. Remember, yeah? Then this is what is called duplicacy, which means what? We have 2.4 percentage of unique records, which is very what we call less. In case if we expect what we call more number of unique values, from this we'll get to know that this is not being expected by the business. So what we could do is we could take a decision whether we need to proceed further or not. So that will be answered by using this profiling. Yeah? Now the next is what? Nulls. So how many records where there is a null data? In this case we have 28 rows where there is a null data. Again, so which means let us say, do we expect like this many number of nulls for this particular column data? If yes, it is okay. If no, then we need to take a look at what are those records where there is a null. Based on that, we would take a decision like what to be done with those records. Yeah? So which means analyst or subject matter expert, yeah, they are going to take care of what is taking a decision after carrying out analysis of each column. Yeah? Now the next is what? Null percentage. Meaning what? Again, this null percentage will be based on what? Null records. So how many records where there is a null? 28. 28 divided by 500 into 100, which is equal to what? 5.6. So that's what we call null percentage. Clear? Then after that we have what we call data type. Can you see here? We have inferred data type and documented data type. Remember, documented data type is the type that will be created based on the source system. I repeat, data type is the type which will be created based on the source system. For example, in this particular example, what we did, we created data object based on what? Based on flat file, right? Which means when you try to import like what we did while creation of a physical data object, that is the type which we call documented data type. In this case, it is a type which is a string with a length of what we call 10, what we call columns, sorry, 10 characters in length. Yeah? String with a length of 10. Now, left side you can see infer data type where we have a string with a length of what we call 10. As I said yesterday, infer data type means what? It is the type that would be derived based on what we call the number of records and based on the occurrence or kind of data that we have from a given source of this particular column. So what this particular tool does is, it is going to traverse through all the records and come up with what we call the generation of type. Yeah? For example, let me just define what we call simple example. Let's say 1, 2, 3, 4, 5 and followed by ABC. Clear? So which means let us say we have this kind of data. Yeah? So what it does here is, in this particular kind of data, it is going to create with a type of what is called string, yeah, with a length of 1, not with a length of 5. This is what we call inferred data type. So I am trying to what we call explain the difference between info data type and documented data type. Yeah, yeah. Let's understand this. After that, oh, sorry. So which means what, while creation of this info data type, what it does is, it is going to traverse through all the records, and whichever the majority of the record that we have, that will be taken as a base while creation of this particular type. Yeah? But when you document, in case of documented data type, you will have what, string with a length of 3. So this is what is the difference. Yeah? So which means what? At the time of import of from the source is what we call documented data type, and then we have what we call info data type, which will be created based on what? Based on the number of or majority of the records of what we have from a given source. That is what happens over here. Yeah? Yeah, this depends on what type of data that we have. A majority of the, what you call, the number of records that we have. Yeah, and with respect to type, all that. So that will be taken as a base in case of info type, and documented is the one which we create while import. H1. Yeah. Clear? So in simple terms, this is based on the majority, this is based on import. That's it, to make it very simple. So now the next is what? Range. One we discussed was duplicacy. Second we talked about null. Third we talked about metadata, which is with respect to type. Right? Then the next is going to be what? Range, which means maximum value and minimum value. So where we are going to understand what is called range of the data, which means what is the maximum and minimum. Yeah. So from that we will get to know, so what is the data, which means what is the upper and lower value for this particular column. So within this particular range only we have the what we call source data. From this we will get to know, let's say we have age which is between 1 and, let us say, 20 or 1 and 40. So which means we got the what is called newly added customers within this particular age, what is called range. Similarly, we can talk about the data based on the month, which means did we get the data from Jan to what we call March or April. So Jan is going to be the lower limit and April is going to be the upper limit. So within that, if we get data, then we can say that okay, within this particular month only we got the data, not other than this. From that, business will take a decision, okay, we need to prioritize tasks during this particular month rather than what we call other months. Yeah? So that is where what we call range is going to help us. Yeah? In this particular case, silver and 1. Within this particular we have data. 1 is a minimum value and maximum is what? Silver. And the last property, which is a summary property, is what? The profile date and time, which means what? On which date, what it call, and time, this particular column has been profiled, is what we call profile date and time. Yeah? So that's where last profile date and time would come. Clear? So which means this will happen what we call based on what we call this particular like column and when we are going to run this particular column. Yeah? So that's what we need to do as part of this particular example. Yeah? Now let us talk about another column. Let us take a full name. Can you see here? There are 492 rows where there is a unique value. Yes or no? What are those? You can see on the right side. Can you see here? Kelly Brown, David Reed, or whatever. Kelly Brown, where we have 3 rows. But anyway, we don't need to worry about detailed properties. For now, there are what you call 492 rows where there is what you call unique values. Yeah? And percentage will be calculated based on what? Unique values divided by total rows, which is 500, which is 492 divided by 500 into 100, yeah? Which is what we need to do while calculation of what we call percentage of uniqueness, yeah? Which is 98.4 rows, percentage of rows where there is what we call uniqueness. Yeah? Clear? So that's what we have, what we call as part of this particular uniqueness. Then the next is what? Null. There is no null data, yeah, that you can see as part of this. So which means if we have null data, then we can see as part of null. If you don't have it, you will not see any null data over here, right? So it's not applicable. Next is what? Type, which is string 1919, which is same. If within square bracket you can see 100%, right? Which means what? All the records have got what we call similar length or whatever, more or less, not all the records, more or less, majority we can say. So it is going to consider majority. And then max and min, which we know, uses and error. So which means minimum value, maximum value. In simple terms, if we arrange the data in descending order, top value is going to be the maximum and bottommost value is going to be the minimum. Yeah? So that's what we call this maximum minimum. Yeah? And last perfect data and time, it means when we executed this particular column, date and time. Yeah? Similarly, we can pick up other column, let's say state, where you can see different what you call percentage. Now, unique values is how much? 39 rows where there is what you call unique, where we have unique values, yeah? 39 rows, and then we have percentage of uniqueness is how much? 7.8%, where there is what I call uniqueness. So we don't have what I call this much percentage of, we have this much percentage of uniqueness, which is 39 divided by 500 into 100, which is what we call what is the percentage of uniqueness or unique records of what you could see over here. Yeah? Clear? And then null data is how much? 81 rows where there is what I call null data and 16.2%, which means 81 divided by 500 into 100 is what we call percentage of null data. Yeah? And then type, data type. So I picked up this column just to show you the difference of what we call percentage of this inference. Can you see here? Documented data type is going to be what? String with a length of 1313. And then infer data type is how much? Which is string with a length of what? 2 with a fixed length, right? So 97.59% of records where we have with a length of 2. Yeah? What are those? You can see on the right side. Can you see here? We have what? CA, NY, WA, AG, OR, TX and so on. Yes or no? Yeah? So which means what? We have this many records, majority. Other records, right? San Ramon, San Francisco and so on, right? They are all what we call greater than what we call length of 2. So that is what you can see as part of this particular what it call output. Yeah. Clear? So this is what we do as part of this what I call this profiling. Yeah. Can you see here? 97.59 means what? That many number of records where they follow with a length of what? 2 characters. Yeah. So rest of them what you call have got more than 2 characters. So as I said earlier, majority of the records will be considered while what is called creation of this particular type and length. Remember. Yeah. So that's what happens over here. Yeah. Okay. Oh, is there any voice disturbance here? Oh, okay. Fine. Is my voice clear or there is some disturbance? No? Chandra,
No, your
Pallavi.
voice is sometimes we hear some cracker kind of sound. Sometimes not.
Okay. Okay, Krishna.
There is some.
Okay. Yeah, it's clear, right? Okay, fine. In case of any what you call clarity issue, right, immediately you can just ping me so that we'll correct it. This should not be a problem actually, but if at all you have problem. Fine. So next is what you have what max and min is we discussed earlier. That's all. So that's about what you call summary properties. On the right side, you can see what detailed properties, which means on the left side you can only see summary. On the right side, we are trying to look at what is the detailed properties. Yeah? Like we said, what is called some records where there is uniqueness, right? What are those records where there is a uniqueness? You can see here. Yeah? Like we picked up what is called first customer tier, right? There are 12 rows where there is a uniqueness, like a diamond, ruby, emerald, bronze, 2, gold, and so on. Yeah? So which is what you can see over here. Yeah? Clear? So which means what we'll have what is called 12 unique values. Now for each unique value, how many number of rows where there is a diamond, which is what we call frequency. Yeah? Which means what we can see here, the frequency of each value here. So in this case, we have 116 rows where there is what we call diamond. Remember, I repeat, there are 116 rows where there is what? A diamond value. And percentage of what we call this particular occurrence, which is diamond, is how much? 23.2. Which means what? How do you get the number of occurrences, which is 116 divided by 500 into 100 is what we call percentage of what we call occurrence, which is 116. So you can calculate that. Yeah? So 116 divided by 500 into 100. So which will be equal to this much percentage, 23.2, right? So that's what you will see here. Which means what? How many number of records where we have a diamond? Which means from that, business people, they will take a call. Okay, majority of the records are based on what? Diamond compared to other values like a ruby, emerald, and so on. Such things also will be identified what we call by using this profiling. Which means what? The how many occurrences of each value, yeah, will be identified here. Yeah? percentage in V, then chart will be derived based on what? 23.2. Clear? Same procedure will be repeated for other values also. Like we have ruby, emerald, bronze, tool, gold, and so on. Yeah. So that is what happens over here. Yeah. Then the next is what detail side. We have patterns. This is the important thing. No? So patterns will be used in order to understand the kind of pattern that the input data follows, which means that we have 7 character pattern, 4 character pattern, single digit pattern, 6 character pattern, null pattern, anything other than the above pattern, which means broadly we can categorize pattern means what? The kind of data that we got with respect to what? Number of characters or whatever. Remember, I repeat, number of characters or whatever. So that is where what we call this particular character, what we call pattern is going to help us. For example, we have a zip code. Now, we need to understand what we call the number of characters or number of digits that we expect in what we call zip code. So how are we going to understand what we call just by looking at the data? So we don't just by looking at the pattern. So we don't need to travel through all the records in order to see how many records where there is a what we call 6-digit pattern that we follow in India. If you take other countries, let's say US and so on, they have what we call 9-digit pattern. So how are we going to identify what we call 9-digit patterns? So such things will be what we call taken care as part of what we call pattern analysis. Yeah? Clear? So pattern analysis is going to help us just to understand the how many rows of data where they follow similar pattern. Yeah? In this case we have what there are 7 characters. X indicates a character pattern and there are 186 rows where they follow what? 7 character pattern, and there are 4 character pattern with what I call 120 rows where they follow 4 character pattern. From this we can understand what I call the kind of pattern that would be followed what I call by this particular input data. Yeah. Fine. So any questions in pattern? Pattern is a very good concept here which is going to help us what we call in order to understand what we call the kind of data that we have, which means what? With respect to characters, with respect to number of characters, with respect to digits. So in simple terms, there are 2 types of patterns. One, string based, other is what? Numeric based. So there are 2 types of patterns. Yeah? Fine. So first we need to understand what we call this pattern. So clear? So that's what we need to understand. Once you understand the pattern, either string based or digit based or numeric based, then we can drill down like how many records where there is what we call 7 character pattern, how many records where there is what we call 4 character, 5 character, whatever. Yeah? Yeah, this is a numeric pattern. 9 indicates what? Numeric, which is a single digit pattern. So where we have 90 rows. Where do you see that? If you go and look at the values, can you see here? 2 with a 52, 3, 20, 1, 18. Sum it up. 52 plus 20 plus 18. Put together is what? 90 rows. Which means what? There are 90 rows where they follow what we call a single digit pattern. So which is what you will see over here. So this pattern will be derived from where the actual values of what we have seen. Yeah? Similarly, 7 character pattern again from values. Can you see here? Diamond, and emerald. So if you put together both, so where they have, yeah, it's based on what you call size of number of characters. So, yeah, Yashwant. So 9 indicates a digit pattern, single digit pattern. Yeah. So if you have more than 9, 2 digit pattern, 2 digits. So which means what? If we have any single digits, right, 0 to 9, all of them will be considered what is called single digit pattern. Yeah. And other things are what? Character pattern, which means what? By default, X indicates a character, within parenthesis 7 indicates number of characters with what you call in between A to G. So alphanumeric means what? You will have X followed by digits. You will have both. Yeah? So that is what happens in case of what mix of both alphanumeric. I will show that example, those examples also. Yeah? Clear? So that's what we have over here. Yeah? With respect to, we talked about character pattern, digit pattern. Anything other than that, again, look at here. It is going to consider majority of the records while calculation of this pattern. If we have 10 records, each record follows its own pattern, then those things will be part of others pattern. If we have what is called similar records with, let's say, percentage more than 5%, then only you can see separate category of pattern, or else we can't see that. Yeah? Fine. So with this problem we'll stop here. We'll continue from here with statistics and rest of the profiling part with the database table also I'll show, and also I'll also talk about some more profiling techniques with some more examples, so that so that you guys can understand better. Fine. If you have any questions, you can shoot out now, yeah, so that we can discuss. Yeah. Any questions? So you can start shooting questions now. Yeah. Fine. If there are no questions, data quality part will stop here. So we need to start now. We need to start MDM. Yeah. So Informatica have data profiling software. Yes, we have both profiling as well as quality. Chandra. Next step part I'll talk about it tomorrow. Yeah. Srinivas. So we have some more profiling stuff. After that, quality would come in. Yes, Ashwin. So let me just unmute so that you can ask question. Yeah, go ahead. If you have a question, right, you can put a question mark so that I'll unmute. So you can just speak out. Yeah?
Like Sima, how can I listen to the recorded session?
Srinivas, sir?
Yeah, yes.
I'll drop an email on that, Srinivas. Yeah?
So
Fine.
Sima?
Any other questions?
Sima, I have a question, Sima. Can you hear me?
Chandra?
Yeah.
Yes, Chandra, go
So
ahead.
my question is, Informatica does have a data profiling software, right?
No, it's a profiling cum quality.
Oh, it's together one software?
Yes. For example,
And
we have looked at
I
what is
remember-
Informatica developer, right? Which is a combination of both. Now we are talking about profiling part. After that, we'll also talk about quality part. Chandra?
okay, and about the workbench that I asked you, so in this version 9, they don't have that workbench anymore, right?
We have, see, workbench just like a, what you call IDE or studio, which will be used to build what you call data quality activities. Yeah. So there was a fancy term that we used to call
Can you repeat this?
9.x versions. So this is a workbench of what we are looking at here.
Can you repeat one?
So workbench in pre-9.x, we use a term called workbench studio, which will be used to build data quality activities. Yeah? So now we can also use the term workbench here also. We are not using it because we gave the what you call Informatica gave the name Informatica Developer. So that would replace what you call workbench.
Okay.
Fine. Any other questions? Yeah, you'll get this what you call PDF Srinivas. I think I've already sent it, Srinivas, yesterday itself. I've sent it, Srinivas. There's an attachment. Fine. Anything else?
Tima, we
Hey,
haven't got
this
it.
is Pallavi. I have one question. Can I go ahead?
Pallavi, on data quality, right?
Yeah.
Yes, Pallavi, go ahead, madam.
Yeah. So I heard some algorithms regarding the identity match.
To what you call achieve restartability features, we need to what you call start building smaller jobs with what you call complex functionality in smaller jobs so that we can achieve restart at checkpointing or restartability from a place where it was ended or where it was failed, which is what need to be what you call thought of while building data stage jobs. And with respect to what you call staging layer, remember, never ever use staging as database stages or a database or any file or any external application. Because of what? There is a need to take care of conversion, there is a need to take care of partitioning, which means what? When you say, let's say output of one job will be sent to what you call database, and again, if you want to use that database as input to again to another job, then what happens here is there is a lot of conversion overhead here. In first job, we need to convert this a job which produces data set to a target which is a database. There is a what I call conversion overhead from this data set to a target understandable form. Now, when we try to use that particular database as a source to some other job, then what happens there? There is a conversion overhead from that particular database to again data set. So which means what? How are we going to avoid that? Use staging as what we call data set, not other than what we call data set. That is where most of the guys, they would make mistakes, by using what I call staging as some database. I think more than 80% of the projects, they would follow with what I call database, which means what, because of many people have got good experience in database side, right? So which is easy to retrieve all that, because the reason why we should not use in databases is what? Because of conversion, not only that, partitioning part which I was trying to talk. So that need to be eliminated being a good what I call designer of data stage. How do you do that? Usage of data set rather than usage of some other storage medias like database or file or applications or something else. So then the next is what we need to think of. There is one good customer, it's a Bank of America, where they use what I call data sets, because they have very large data where they follow what I call staging as data sets. So one thing is you need to make sure that you have enough space which is very cheap, so which we can buy easily, right? So that's not a problem. So, but maintainability part will be a bit complex. For that, you have to have good expertise on how to make use of data set. For that, we have several command line options, right? Some of them I've explained that by using arc-admin. So that part you need to know. If you know that, then data set is always decided over what we call non-data sets, which is database applications or files or whatever. Now the next is what this is a small what I call general concept that is applicable for any kind of job. Start small and go with what is a complex and to reach what I call final target, which is going to be the final solution. Yeah? And next is what with respect to what a configuration file. See, data stage is very good because of what this config file concept of what we have, which means partitioning concept, which means configuration file that requires at least 20 hours to explain, minimum 20 hours. Yeah? So I'll just touch upon very high level. I think I talked about some of them, which means what config file is what we call is the important node config file, which we need to configure what we call clearly, like which node are to be used effectively for this stage, which is going to be the question mark, which means what you need to know how the stage works and how the stage works on this particular, let's say, physical mission, and how it is going to behave, and how many number of what you call or how much of memory that is required, how much of disk is that is required, how much of CPU power that is required for each stage or each partition. Based on that only you can configure node configuration file. What normally people do is, because we have config file, just go and add some just nodes, which is config node 1, node 2, node 3, node 4, and somehow get what you call parallelism. That anyway you will get it to some extent, but not to a large extent. In order to get there, you need to have other factors which I was trying to talk, which is what memory part, disk, all that. Yeah? We need to think of those factors while configuring this config file. Yeah? If you do that, then you can utilize the resources of what we have in each computer effectively. Yeah? So that's what we need to think of. But while building a simple job, you can just go with a single node, don't go with a multi-node configuration. But when we try to optimize, then use right number of nodes for a right job. Yeah? Depending upon the amount of data that you need to process, depending upon the number of applications that are up and running in a what you call data stage environment, and also what you call impact of what we have of this particular job with the rest of the jobs. So those factors we need to keep in mind while what you call supplying number of nodes. Yeah? There is one example which I can talk. There is one what I call idea telecom customer, where they used what I call many number of nodes for many jobs, which resulted what I call lot of resources or resource crunch issues on that particular environment, which is a telecom environment. So which means what? How are we going to what you call fix such issues? Because what they have done was because they have what you call environment, which is they have what you call config file concept. They have just what you call kept on adding too many number of nodes, which resulted what you call consumption of lots of resources. So which resulted what you call lot of issues of generation of output in that particular environment. So which means what? We should avoid using too many number of nodes. Use more number of nodes if it really makes sense with respect to what I call factors which I was trying to talk. One, based on applications that are up and running in a data stage environment, and second, like how much data that you need to process, and third is important thing, which is what I call is this particular stage is what I call CPU intensive stage or memory intensive stage or disk intensive stage or IO intensive stage. Those factors also we need to think of while what I call usage of this config file. Remember. which is very complex part. Even if you, let's say people who have got even 14, 15 years of experience in data stage also, they themselves find difficulty on what you call usage of right resources. That's what has happened in this telecom industry, right, where we have worked, where they had very good experience, very experienced guys were there who built a solution. But why still we got those issues? Because of that they had only tool expertise, not peripherals, which means what being an architect or designer or solution provider of that particular data stage, right, we need to have even peripheral expertise also, not only data stage. See, data stage anybody can build a solution, which is a drag and drop, right? Anybody can do that, which is not a complex thing. But building an effective solution is a complex part. That's where real experience is going to play a role. Yeah, so now, which means what, use config file effectively. That's a conclusion. Let me not get into the details. Now, complex job into smaller jobs, I think I've said that. And this is how the final job would look like. This is with respect to best practice perspective, from the designer, not from performance. There is a question from where, can the data be staged in sequential files? We should never ever do that. Why? We can stage it. You can stage to file, we can stage to database, you can stage to application, you can stage to mainframes, you can stage to what you call some other types of storage media. But we should avoid doing that. If we do that, what happens is there is a overhead with respect to conversion and with respect to partitioning. That, to avoid that, we need to use what we call data sets work. But we can stage to any media, so data stage allows that. And that's what, as I was saying, most of the companies, wherever they have built solution, right, with data stage, so where they have used what you call databases and files, which is not at all recommended from the data stage, because not only data stage, even any other tool also, they have their own proprietary or internal format. We need to stick to that. Because we have some databases we can store it, doesn't mean that we should just use and store it. So we should not do that. Fine. Now the next is what, this is how we need to build, which means what, from the design perspective. Here we have full documentation part, the usage of containers and usage of all good stages, and then also usage of data sets here. Can you see here? In this particular case we have data sets. So that's it about best practices. Plus the good things with respect to debugging and with respect to performance. So make sure that we are going to enable this dump score, where this is going to help us a lot, like how many number of processes that would spawn for each job. So if we enable that, you will get a what is the complete score, which contains what we call all the processes that are required for a particular job. Plus we can also have what we call total number of processes that are spawned for this particular job. Plus we also have what we call interaction of one operator or one stage with another stage. Plus you will also have what we call is it a combinable stage or non-combinable stage, or combinable operator, non-combinable operator. Plus you will also see the number of virtual links, which means virtual data sets or data sets that we use, which means what, you will get lots of information within this dumb store. That is why in case if you get stuck with what I call something in data stage, yeah, we need to debug, right? To do that, we always need to enable this and see like how many number of things that I was trying to talk. Yeah? All of them we can obtain from there. Plus, we can also use this in order to optimize data stage job, because you will get to know how many total number of processes that are spawned for this particular job. Plus, you can also see the number of links, which could be, let us say, virtual data sets or whatever. Plus, you can also see the kind of partitioning techniques and collection techniques that we have used. So based on that, what we can tune data stage job. This is one of the what I call environment variable, which is going to help us a lot. There are many more. I'll talk about some of them. And next is what we have, config file, which I was trying to talk some time ago. So config file, basic what I call goal of config file to achieve parallelism, especially partitioning parallelism, right? Yes or no? Let us say you have 1 billion records or 1 trillion rows of data that need to be processed. Yeah? So we can process that by using single node or 2 node or 3 node or 4 nodes. But how much is the time or the SLA that is required in production? So based on that, we need to define a number of nodes in a config file. Not only that, other factors I was trying to talk, right? Apart from those factors, I added one more. And then, so with this, what we call config file, you will see the effect of degree of parallelism, yeah, whether it is going to be 10 minutes, 20 minutes or whatever. Yeah. Plus, we also have what we call disable combination. There is one environment variable which will be used in order to run each stage in a separate process. Remember, for example, let us say we have 10 stages. That doesn't mean that there will be 10 processes spawned. Yeah? There could be what I call 3 processes or 4 processes or 10 processes. We don't know. That depends on the kind of stages that you have used in a given input job. Yeah? But in case if we have enough number of resources, or in case if we have any issue with respect to data stage job, then what we could do here is we can enable this disable combination is equal to true, which is going to result what? It is going to spawn a separate process for each stage. Remember, yeah? For example, if you have 10 stages on single node configuration, then you will have 10 processes. Yeah? So this will be guaranteed if we enable this. So if we have a separate process for each stage, then it is easy to what we call debug by attaching the debugger to each process. But if we have many stages, let's say 10 stages have been combined into single process, then it is very difficult to isolate a problem like on which stage there is a problem. Yeah? To avoid that, what we are going to use what we call disable combination equal to true. If we set that, each stage will have a separate process. So with that, it's easy to what we call debug. Yeah? Like which stage has got the problem. There are some more what we call types or modes of execution of data stage jobs. I'll talk about that. Data stage Yeah, I don't know what happened suddenly. Yeah, I think now you can hear me, right? Okay. So I was just trying to talk about the disable combination part. So so make this as a true, this variable value as a true, in case if you want to debug data stage jobs. Yeah. So because every stage you will have separate process. So if you have separate process, we can attach a debugger to each process so that we can isolate a problem, like which stage has got what kind of problem. And then the next is what job parameters. Remember, if you think from the best practice perspective, always use what you call, try to parameterize as much as you could. In this particular slide, you can see username and password, source directory, datasets, and so on, right? So don't try to hard code these values. Instead, go with the job parameters, because we all know that in any project you will have dev environment, testing environment, and production environment. Yes or no? Yeah. And now in each of these environment, what you call, the input parameters will be different. For example, in dev environment, database credentials like a username and password, data source, all that, right, would be different from QA or testing environment and production environment. Yeah. In such cases, if you hard code the values for such parameters or variables like user ID, password, all that, then we need to hard code wherever we go, which means if you go to testing, again we need to hard code. So in such cases, go with what is the parameterization, so that we can avoid with what you call hard coding stuff. Yeah. Not only that, even if you think from the performance perspective also, parameters are going to help us a lot, especially when you have buffers. Yeah. Let's say if you have defined buffers for each stage. Remember, data stage is very Gaussian actually. So buffers concept is what, let us say, the buffer size of what we use for stage 1 would be different from stage 2. Let us say, how are we going to what it call differentiate this buffer sizes? So in that case, what we could do here is, first of all, you need to understand how each stage is going to behave if I change the buffer. Yeah, that's a prerequisite anyway. And once you know that, parameterize each so that the value can be what you call changed depending upon the stage. Being a good designer of data stage, what you need to do is the buffer sizes should be different for different stages, because the way each stage works is different, right? Yeah. So to that extent we need to go if we talk about performance. Let me stop here. And now the next, this is how the dump score would look like. Can you see here where we have two sections? One is what I call operator section, which is in the bottom. Can you see here? So where you will see what I call three operators, namely OP0, OP1, OP2. Yeah, it is indexed. Now we have what I call corresponding stages are generator, first peak, second peak, and so on. Yeah. And now the next part is what? OP0, which has got one process. We can see in the square bracket, right? How to read, I am trying to explain. And now on which node this particular stage or operator is going to execute? On node 1, which belongs to what we call partition 0. Remember. So which means row generator is going to get executed under partition 0, which is node 1. Yeah. And then we have what is the operator 1 has got what we call 4 processes. Can you see here? Which means it is a parallel stage or parallel operator, and which is first parallel peak, which is running on 4 nodes, namely node 1, node 2, 3, and 4. Yeah. And operator is what? Only one operator, which is first peak. And then on which nodes? Node 1, node 2, node 2, node 3, node 4, right? Corresponding partitions are P0 to P3. Similarly, operator 2, which is running on several nodes. Yeah? And this is what we call operator section. Complete section is what we call operator section. Yeah? Now, the next is what total number of processes that are spawned for this particular job. Can you see here? Here we have 3 stages in this particular job. Yeah? And we have what? 9 processes and 4 nodes. How do you establish relationship over here? Yeah? So which means we have 3 stages, let's say 4 nodes. 3 into 4, it should be what we call 12 processes, right? But we have 9 processes only, because the reason being row generator is going to get executed only in sequential. So where 4 nodes have been cut down to only 1, that is gone. So rest of them 4 plus 4, 8. Yeah? So 8 plus 1, which is row generator, which is 9. That's how the calculation happens. Remember, in data stage, there are some stages which will be executed in parallel, some stages which will be executed in sequential. Plus, I was trying to talk about previous slide, it's a disable combination, right, which is also going to play a key role while what I call creation of this particular dump score with total number of processes. Yeah? So that's about what I call operator part. Yeah? Now, once we understand this, then on the top you can see what we call data set section, where you have what I call data set 0, data set 1. From where we got this data set 0 and 1. So data set 0 belongs to what I call first output link from row gen, and data set 1 belongs to what? Second output link from first peak. Yeah? Now, you can see here what is the relationship between what I call one operator to other operator is what? ENE, which means what? Relationship between partitioning and collection, which means what? Auto. If you select auto partitioning method, then you will see any over here, and if you see auto collection method, then you will see collect any. If you specify explicit partitioning, what you call algorithm, let us say round robin or entire or range or whatever, then you will have appropriate what you call partitioning over here. Similarly, on the right side, you can see collect any, which means what? We have round robin, order, and we have sort merge. We have 3 algorithms, right, to collect the data. So which means what? In order to what you call establish the linkage between partition and collection is going to be what? Any partitioning, any collection, because of what? Auto. So which means we will leave it to the data stage to take what I call a call, like which is the best what I call partitioning and collection to choose. So by default, every stage will have appropriate partitioning type, which is hard coded anyway. But if you want to use explicit partitioning, then we can use a partitioning tab where you can see different partitioning algorithms. And then in bracket, in curly bracket, you can see OP0, which is operator 1, which has got one process, which is what? Row generator. And then OP1, which is what? Parallel peak, which is running under 4 processes, which is 4 processes, which is what? Row gen 2, what? First peak, you'll have 1 to many, which means what? There is a 1 row generator with 4 parallel peaks, which is 4 separate processes, remember. So Rosen need to produce many records so that 4 processes belongs to peak will be taken care of. Anyway, parallel means what? They will have their own way of what performing tasks, which means they would take longer time to what you call produce the output in a target, which is in the console, which is std out or std error. So which means this guy produces, let's say, 10 records. So each let us say that what you got 10 records will be split into 4 partitions, and then data will be sent to peak. And similarly, DS1 between what? First peak and second peak, which is a link, right? This one. Yeah? This you will see over here. NE2 collection. And then first peak is a parallel peak, which is the first one, and second peak is this. Again, between partition and collection is what? Any. That's it. So which means what? Broadly, you will have 2 sections within this core. Yeah, and from this you'll get to know which operator is going to get executed on which route. So that's what we could say over here. That's it. That's about dump score example. Yeah. Multi-node configuration file, which is a simple thing. Just to copy paste, change the node name. That's it. To make it simple, but to optimize it, we need to think of resource disk, we need to think of resource cache disk, we need to think of node pools, which is a complex part. So for that we need to know all operating system things which I was trying to talk earlier. Yeah? Containers, so we all know that. I will not talk much because this is very straightforward. Just to have or just to build reusable functionality, we can build a container and use that container like wherever you want. But if you think from the performance perspective, containers are not recommended. But if you think from design perspective, containers are very good. Yeah? But if the input data is small, right, and it's a marginal what you call performance hiccup we have, but if you have very large data, then you will see the effect of container to a large extent. And now relational data, which is a very what you call complex part, which means this is a parallelism, right? This is a old architecture with the database. With it, this is with what you call data stage. So we use data stage enterprise edition, right? DSE, which means what? This is just a fancy term. It's just a parallel. Enterprise edition means what? Parallel edition, nothing else. No? So which means while loading the data from, let's say, one parallel stage, which is sort stage 2, target, this will happen in parallel. That's all this diagram represents. No? But in previous case, if you have n number of points, here are n number of connections. For each connection, there is separate what you call client. So which is laborious part, which is what you call traditional part. Here, one connection, multiple parallel partitions. So that's about what we call this load database part. How to create all that, we all know this. I'll focus on the optimization perspective. Yeah. Here, while writing a query, what we need to think is we need to build optimal query. You know, like we have what you call usage of less number of joins, indexing, all that, right? These are normal database concepts we need to think of while building a query. That's one thing. And parameterization for best practice perspective. That's all we need to do. And minimize the number of columns. Don't use all the columns unless otherwise they are needed to be transferred to what you call downstream stages. Yeah? And yeah, then the lookup. See, lookup is a very good stage and very easy stage, and use this stage in case if we have what you call enough memory where you can fit all the records that you have in database can be fit into the memory. If you don't have enough memory, then don't use this particular lookup stage. Yeah? So there are different types of lookup, sparse and normal lookup. Use sparse lookup in case if we have larger number of records in a reference table than compared to source data. Yeah. But otherwise, go with what you call normal lookup. That's one thing. And next thing is what this Oracle or database stages, don't use them for reference length. Use, there is a file set, there is a data set. So data set is a difficult here. So file set is a good, what you call, lookup file set we can use here, so that it will be much faster compared to database or sequential file or application. So how many maximum records recommended for lookup? It depends on the memory where. So it's not based on the number of records. If we have, let us say, 20 MB is the memory that you have reserved, then you can have that many number of records, which means record means again each record can have 10 columns, 20 columns, 30 columns, whatever, right? So it varies. Let's take what you call an example, 10 columns, and each record would consume, let us say, let's say 500 KB, kilobytes. Then we need to think of what you call, then you can convert that to number of records, 500 kilobytes into, or sorry, 20 MB divided by 500 kilobytes. So that many number of records you can process. Yeah? Which means what, let us say 400 or 4,000 or 4 million, whatever. Yeah? So that's what, that's how we need to calculate. Yeah? And make sure that we are not going to hit thrashing or overhold issues with respect to this disk issues, disk and memory and virtual space issues. Yeah? So those things you will get into if you use, if you don't have enough memory, yeah, where we use lookup stage. Yeah. That's what, all these things we need to think of while designing data stage. Yeah. So see, combinability can be done many stages. We have join is there, lookup is there, merge is there, funnel is there. Yeah. So whatever can be done in lookup, most of them can be done even merge and join stage also. But when to use what, that is going to be the question mark. I think we talked about that yesterday. Last sometime previous, I think yesterday we talked about that. Now, right side, which means while writing data to a target, which is going to be the database, use the right method, yeah? Correct right method. Yeah? So which means use what you call truncate, which is going to be the best option. Don't use what you call upsert unless otherwise required, or else it needs to first check, update, if not insert. So there's a lot of checks that is going to take place. Yeah. So that's about these things. Yeah, this is where upsert concept here. Yeah. Can you see here, right side there is upsert which is selected. So that's it about what you call database as a writer and reader. Then compilation part. Yeah, this is the overhead stage, right? Transformer stage. I think I want to talk about that. Yeah. In data stage, remember, from client side if you think, we use these terms, and engine side you use these terms. I think you guys don't need to remember engine side, because that needs to be known by the real developers of engine, which means programmers. For you guys, you just need to know terms. Okay, link equal to virtual data set. So you should not confuse. See, here the wrong thing here. Stage is not a stage here. Stage is what operator here. Yeah? So now export import, we do it by using repository manager T9.x, sorry, T8.x. From 8.x onwards, we can do it by using design itself. So that's it. Yeah, this is a complex. Remember, I think we all know that when you run any job, right, in data stage, what do we have? We will have what we call startup time as well as production time. Yes or no? There are two measuring attributes that you can see for each and every job. Yes or no? No? So which means startup time will be used just to get like how much time that it has taken by each job to start it, which means what time taken to start a job. Yeah. So for that, if you want to get detailed information about that, there is an environment variable which we call startup status, which is going to help us to get more details in case if we have any issues while starting a given data stage job. Then enable this variable so that we can debug that kind of what we call issues, which is starting issues. Yeah? So which results in what we call score all that. And fork join is a concept of what we call buffers, which I was trying to talk. I didn't elaborate. So back now is the term here, fork join. I need to elaborate to some extent. Let's say we have one input link, two output links, one target, which means what we are just forking into two processes and joining it. You know, it's just like a diamond rule that we adopt here. So what happens here when you fork here? So what happens? You'll have two output links, and if you try to join two output links data on target, then what happens? Which link data will be sent to a target? Is it going to be the first link or second link, or are we going to make both of them in what we call in sync? That's where fork join, which means there is a concept of what we call deadlock, or there is a chance of having deadlock. So let's say one guy has finished one output link data, what we call is produced, it got kicked off. Then after that, other output link, which is depending upon what say some other output link. So it will be waiting for the resource to be released from previous output link, which is already done. So what will happen? There is going to be what we call deadlock. So how are we going to prevent that? Insert what we call buffers. So that's where buffer concept, which means why if we insert this buffers, it inserts what we call stages within data stage, where you can see in the score. Yeah? That anyway, that's a different story inside. But to avoid these deadlock issues, make sure that you insert buffer, which means define the buffer size so that this stage, which means what upstream stage and downstream stages are going to equally what we call work, which means if first stage is produced as a 10 records in first output link, second output link was more or less same, then what we call there will not be any deadlock issues. If the one guy produces 100, other guy produces 10, then there is a chance to have what we call deadlock. So that need to be eliminated by using what we call proper buffer size for each output link, so that as and when this guy reaches that particular buffer size, it is going to wait, though it is going to produce what we call too many number of records. Such things will be eliminated by inserting what we call buffers. This is going to be the not only just avoiding deadlock, this is also going to help us to optimize data stage job. Yeah. So score, I think I talked about what score, what do we get from the score, or the number of processes, plus PID, which means in case if you want to debug, right, you need to know process ID. To do that, enable that show process IDs, then you'll get PID, attach a debugger, then debug it. So that's what need to be done as part of what we call debugging on this. Srinivas? Be used in order to what we call divide the input job into multiple what we call sub jobs or multiple processes so that the job would get executed based on this particular what we call number of processes. In this particular job, we have what we call one conductor node, and we have 3 node configuration here, which means if you have 3 nodes, then you will have that many number of section leaders. So which means if you have 3 nodes, 3 section leaders, just remember that. And bottom part is what? Players, which means for every stage or for every operator, you will have corresponding player. For example, in this case we have generator operator, we have generator player. On this particular node, which is a first node, which is 0 index, then followed by copy or peak, then output of this generator will be sent to copy stage or copy operator. This is one partition belongs to this particular section leader. Similarly, under second node, we have what? Generator and copy. And third node, we have generator and copy. So there are 3 nodes. There is a 3 node configuration. So you will have what you call 3 sets: generator, 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 copy, copy, copy. That's it. And corresponding section. There are 3 sections, right? Now let us talk about the flow of activities. Conductor does what? Conductor, it is going to, it will be the starting point for data stage job. This means for every job, you will have one conductor process, which is going to be the main process for or entry point for data stage job. So which will be used to compose score, which means what? Score is a combination of a job, which is this, plus config file, which means what? It is going to take 2 inputs, one a job, other config file. Based on that, it is going to create what we call a temporary understandable form, which we call score. This is what I was trying to talk. There is a score composer within this conductor process. What it does is, it is going to create a score by taking the data from job and also from config file and form a intermediate storage or intermediate understandable format, which we call score. Score, I think we have seen one example of score, right? How the score would look like. This is the score example. Now the next is what? It is going to spawn what we call section leaders, depending upon the number of nodes that you have configured within what we call data stage. For example, if we have 3 node configuration, then you will have what we call that many number of section leaders. So let us say you have 3 computers, computer 1, 2 and 3. Then how are we going to spawn? Spawn here is just not like a fork that we have in operating system. Here spawn is equal to what? Remote shell. Which means what? Remote logging of that particular computer, like a RSH, REMSH or whatever, SSH or whatever. We have different remote shell commands which will be issued by this particular conductor based on the number of nodes that you have in a given configuration file. Now we log on to that particular what we call computer. 3 computers were logged in. Once you log in, right, each node, it will work on its own, which means generator peak. Let's say if we have 90 rows, 30 will be sent to first section leader, 30 will be sent to second section leader, 30 will be sent to third section leader. Now it is up to that particular physical computer to take care of responsibility of processing those records, which means generator with a copy, which means these 2 stages will be used to process 30 records on that particular node. Similarly, other nodes will happen. So which means this guy is going to form a score and then remote log on to this particular guy through remote shell. Once you do that, then once you could able to establish the connectivity, this guy is going to send a score to this particular each section leader. Why? And score would contain like which stage need to be executed on which node. Yeah? You will have that much of information within this particular score, right? For instance, this particular peak is going to get executed on all these partitions, yeah, on all these corresponding nodes. That information you will get it from the score. So this guy who conductor is going to send a score information to all the section leaders. In turn, section leader is going to delegate that particular score to respective what you call players or operators, where they need to execute like wherever they have been assigned to, which is generated on first node, which is 0th index. Similarly copy. Similarly on other nodes. That's what would happen with respect to score, what you call usage. Yeah. Now the next thing is what section leader in turn is going to spawn, which is going to pure forth, which is what we call creation of process, right? It is going to create a process, generator copy, and establish the connectivity, which means what, how are we going to make, or how are we going to make this output of the generator, which would become as input to copy stage. That is going to take place based on what? Based on what we call this link, which is what dotted line with arrow, right? What it does, it is going to transfer the data from generator to copy stage. How? Based on what we call this particular link. Yeah? Which means this link could be a shared memory, TCP/IP, or sockets. Sorry, TCP/IP sockets, shared memory, or pipes, or Unix datagrams. So one of these IPC mechanisms will be used in order to make the output of this particular one stage, which will become as input to another stage. That is what you will see as part of this particular connectivity. Yeah. So clear? So gen and copy. Yeah. Similarly, second gen and copy, third gen and copy. So which is what you will see as part of this particular diagram. Yeah? So those are the IPC mechanisms which I was trying to talk. Yeah? And once we are done with that, there are different colors, right? Like we have control channel, which is legend is what black line, right? Which is what conductor to section reader to copy, which means what TCP/IP channel, which means from here to what is the conductor to section reader communication happens through TCP/IP, and section reader to what we call stages is going to take place through what we call TCP/IP. Now the next other is what red line, which indicates what STD out, and blue indicates STD error, which means let us say now something goes wrong in one of the stages, need to be communicated to what we call upper processes, like we have section reader conductor. How do you do that? That will be done by using what? This STD out, STD error. If something goes wrong, there is an error channel, right, which is what? Blue. So copy fail, let us say, this failure message will be sent to section reader, this will be sent to conductor reader, conductor is going to broadcast that to all the section readers. Oh, there is a problem in this particular node associated to copy stage. So go down, which means what? We are going to broadcast that particular signal to all other section leaders. Who does that? Conductor. Then section leader is going to notify to all downstream players or operators. They need to perform their task and come out from that particular task. So that is what is going to take place with respect to what we call handling failures. And STD out channel like I think we have discussed in director, right? We have different logging messages, right? From where you'll get that through STD out channel, which is what red line, which you can see, right? As and when the generator or copy is going to produce some data or some logging messages, those things will be sent through what we call STD out port to the conductor, then on to DS server, then on to client, where you could able to see the messages in the director. That's what would happen with what we call STD out messages. Same thing for STD error also. STD error is also like a what we call error message that will be flown through what we call blue line, which is STD error port, yeah, which is what you will see over here. Yeah. So that's about STD error port, and then we have the same process will be repeated for others. That's all. So we also have APT communicator, which is dotted line with arrow, which indicates what IPC, which means how are you going to make these stages to talk to each other through APT communicator, which will be either TCP IP, shared memory units, datagram, or pipes. One of these IPC mechanism will be used by default shared memory under SMB box, symmetric multiprocessor environment. Under MPP, we are going to use TCP IP, yeah? So which is what happens with respect to APT communicator. So I'll not get into the deeper aspect beyond this, so I think you guys might not be able to understand. So let me stop here with respect to this parallel engine architecture. Yeah? So that is what we call score part, which we have seen already. So yeah, there are different environment variables. This is where I need to talk with respect to debugging and performance tuning. Yeah. So we have different environment variables that we need to think of while what I call debugging or tune at a stage. Yeah. These are this is what I call environment variable starting point. And in parallel category, some of them have been shown here, not all of them, and probably I'll talk about this with a tool, so that it will be easy for you guys to understand. So some of them, like let me talk about them. But see, we cannot do these things in practical because we need at least 6-7 months to cover all these variables. Yeah? It's not that straight to what I call reproduce and start looking at the output for each and every variable, right? So that's what I said. Data stage is very Gaussian. Yeah? So, but some of them I'll try to talk. Yeah, yeah, operator specific variables we have, and reporting variables. Yeah, these are the variables which you guys need to think of while getting the more logging messages to debug. You can say that these are all reporting or debug variables, yeah, which you can use. One of them is the dump score, which we discussed just now, right? Where you'll see the process information, operator information, and link information, like partitioning and collection, all that. Yeah.